Hi friends, in the previous videos we discussed about the strategies that needs to be followed at the time of preparing for GATE examination, right? Now it is the time to go into the core subjects of mechanical engineering and have a deep study of each and every subject, right? So we'll start with thermodynamics and we'll pick up one by one all the subjects related to GATE examination as the time comes. Now to start with any subject, we first need to know the meaning of that subject. So what is the meaning of thermodynamics then? Actually thermodynamics is a combination of two terms. Thermodynamics. Thermo represents energy and dynamic represents its conversion or flow. So basically what we study in thermodynamics is the conversion of one form of energy into another form of energy. Now the next question comes in our mind, what are the different forms of energy? Basically in thermodynamics there are two forms of energy. One is work energy and another one is heat energy, right? The temperature of any body represents the heat energy associated with that body. Now what is work energy then? Now if we do any action to the body, in response to the action, whatever displacement the body gives, it will represent the work energy associated with that process. So these are the basic two forms of energy, heat energy and work energy. So in thermodynamics we study the conversion of heat energy into work energy and work energy into heat energy. For this conversion something is required. Now what is this something? This something is working fluid. Now the next question comes in our mind, can any fluid be used as a working fluid for this conversion process? Answer is no, because there should be certain characteristics that must be associated with the fluid so that it can be used as a working fluid. What is that property? So we'll understand this with an example. Suppose I have a container. In the container I have taken some amount of water. Let us assume for the case that water is incompressible, right? Now if I put above the container piston so that it can move freely in the vertical direction. Now as I heat the water, the temperature of water will keep on rising. Okay, is it possible to raise the piston just by giving heat to the water? Is it possible? No, because just whatever heat we are giving, it will utilize for the temperature rise of the water. It will not get utilized into the expansion of water. Why? Because water is incompressible in this case. So incompressible is the property of water which restricts it to be used as a working fluid for conversion of heat energy into work energy. Now if suppose in the same container in place of water I have taken air. Now if I give heat to the air, it will try to expand because it is compressible, right? So in the process the piston will automatically come up. So I have given a displacement of certain amount, say delta. In the figure I have shown the same experiment. The displacement is delta. So the heat input del Q I have given, I got the displacement delta which represent del W work in the experiment, right? So this is how the conversion of heat energy to work energy takes place, right? In the similar way, if I compress the piston in the opposite direction, the same amount of heat will get rejected. So in this way we can convert heat energy into work energy and work energy into heat energy. The condition is the fluid must be compressible. Now let us start our study with certain terms which are very important from the perspective of thermodynamics. System, surrounding, boundary, universe. So what is system? If we go into the bookish definition of system, system is the area of concern. System is just the area of concern in the whole experimental setup. So let us understand this definition with an example also. I have a container. In this container is closed and is filled with full of water, right? And I have another coil is there. Now it is given in question that temperature of water is 50 degree and it is maintained at that. Okay. Now our aim is, I have written my aim, to study the variation of temperature in coil. I just have to study the temperature variation in coil. So my area of concern is just coil. I just need to study the variation of temperature in coil. I do not have to worry for whatever is happening with the water, whatever is happening with the container or outside the container. So in this experiment only coil is the system, the rest water, container, outside the water, whatever it is, it will come under surrounding. And if we merge together like coil plus the rest of the surrounding, then it will form the universe. Now if we look at this experiment in the opposite way, like I have fixed temperature for coil, suppose 40 degrees Celsius, and I need to see I need to look at the variation of temperature in water. So in this case my primary area of concern is water only. I just need to calculate the temperature variation of water. I do not need to worry what is happening with the coil. So in this experiment my system will be this water and the rest of the thing will be surrounding. Now what is system boundary? The imaginary line that distinguishes system from the surrounding is the system boundary. In the experimental setup I have shown with the red dotted line. This is system boundary, right? So this was all about system, surrounding, system boundary and universe. Now coming to one more important term in the thermodynamics, that is properties. What is property? Property is just a characteristics of the system at particular stage. We just need to know what are the few characteristics so that we can define the stage of a system. Suppose I have a glass of water. If I just tell you that I have a glass of water, you won't be able to tell anything about it. But if I tell you that it is a 5 liter, the amount of water is 5 liter, the temperature of water is suppose 40 degrees Celsius, so you will get the more information related to this glass of water. So this is what happens in thermodynamics. To define any system, we need to specify certain characteristic properties. These are called thermodynamic properties. So again, these properties are classified into two types. One is intensive property, the another one is extensive property. What does this intensive property mean? Intensive property means it is independent of mass, independent of amount. What do this extensive property mean now? It is dependent on mass. So let us take another example to understand this concept also. Suppose I have another control volume, not control volume, another system 1 plus 2 in which gas is there. Okay, now I have calculated all the quantity of all the properties of this system. Suppose what is volume I have calculated, what is density I have calculated, what is temperature I have measured, everything I know about the system. Now I just draw an imaginary line which divides this whole system into two systems, 1 and 2. Now if I compare only system 1 with the initial system 1 plus 2, then what properties has changed? Volume, definitely it is changed. So volume, it means that volume is an extensive property. Now talking about density, is it changed? No, density do not changes. So that's why density is intensive property. Talking about temperature, temperature is also not changing in the in just dividing the system into two halves. So it is also intensive property. Now talking about total internal energy of the system. Internal energy is just the energy associated with the system. So it must depend on mass. If the mass of the system is more, energy will be more. If mass of the system is less, energy will be less. So internal energy do depend on the mass of the system. So it is an extensive property. Now talking about specific internal energy. What do this quantity is? Whether it is intensive property or extensive, it is intensive property. Why? What do this specific term mean now? We need to know this term. So specific quantity in thermodynamics is actually quantity per unit mass. So specific internal energy, in that case what will happen? Internal energy per unit mass. So already we have divided the internal energy by mass, so it is obviously independent of mass, it is per unit mass. So therefore specific internal energy will come under intensive property. So these are the just few terms related to thermodynamics. So it was the first lecture on thermodynamics. I will be putting series of lectures covering almost all the portion related to GATE examination. We'll start with basics of thermodynamics. We'll go through the first law, second law, entropy, and even availability. So, and afterwards we can parallelly we can start with the other subjects also. So if you like the video, please do press the like button and please subscribe my channel so that my videos can easily reach to you. Thanks and all the best.